Okay, so let's continue on with a little more detail about the PRT motherboard. I covered these jumpers here, of course, when it comes to setting the voltage of the center row of positive pins. But there's a jumper up here which is worthy of note. This jumper, actually, what it does is it bypasses this switch. Okay, and this switch is the one that primarily turns on the processor and this side of the board. Okay, so if I want to turn on power to this side, then I have to put this switch to the on position. If I want to turn power to this side over here, then I have to put this switch to the on position. All right. Now typically what we do is we hook our motors up to this side so we can have our servo motors running with their own switch. So that way if I want to do code upload, or if I don't want to worry about the robot driving off the table when I upload, if I have it here, I can just turn on and off the motors and still leave the processor thinking, so I can see whatever data is actually being collected on any of the sensors, for example. But if you'll notice, there's a strange thing about this switch. Right now it's on the on position, so if I had batteries plugged in here, this thing would be running and it would be fully autonomous and ready to go. Now when it comes time to upload code though, I won't be able to plug in the USB cable unless I turn the power off. So now I can turn the power off and plug in the USB. Well, when I plug in the USB, that actually has its own source of power. So it automatically turns on this whole side of the motherboard by simply being plugged in. All right? Now, going back to the jumper. As it turns out, some newer computers, they don't have very much power coming through the USB, which is why now you have, charging ports and things in your computer, because you can't even charge your phone on some of these USB ports. So if you have a low-powered laptop, what you can do is put this jumper across it like this. All right? And what that does is it bypasses the switch. So now this board is getting power from both the USB and the battery pack. With the jumper here, it's getting power only from the USB. Okay, so it's only coming up here. Now the downside of this, the thing to be cautious of, and it's really not much of an issue anymore as it used to be, is with the jumper in the on position and the batteries plugged in and the USB cable connected, it means that it's possible to backfeed power up your USB cable. Now, again, it's not so much an issue anymore because most all the contemporary computers that I've seen now have a circuit breaker that turns off in the event that there's power surge on the USB. And you've probably even seen it sometimes where it just temporarily turns off and then you have to wait some time and it turns back on again. But this jumper is very important if you're going to try to run your robot while plugged in. Okay, so while it's plugged into USB, and if you're using a something like a Surface Pro or any of the Macs, they just don't have enough power coming out of the USB to run the motors. So you put the jumper in place, plug in the batteries, and now you have the system bypassed and you should be able to run it. So that being said, the next thing to talk about ever so briefly is this additional port off to the side. And I'm going to tilt this. You can see it's labeled, so we have a VCC, a ground, a TX, and an RX. That TX and RX means transmit and receive. Now this port, you can use it for any one of a number of things. That transmit and receive actually just go to pins 0 and 1, and I can show you that on a pinout. But it's actually designed for a device like this. So you see it's labeled VCC, ground, TX, RX. If I plug this guy in like this, what it does is it connects this Bluetooth module directly to the power, the ground, and the transmit and receive, and you're ready to go right now. You can just program this thing and you can have it connect to your phone or whatever you want to with Bluetooth. This other one down here has a similar conformation, but it is a little different. We've got VCC, we got ground, and then we have RX and TX. So that was actually designed for one of these guys, okay? And you can see VCC, ground, we have the RX and the TX in the set. So if you plug this guy in right here, you now have Wi-Fi that gives you the ability to communicate with another transmitter, receiver, or any one of a number of different devices up to about 1,000 meters line of sight. Okay, so this is a pretty powerful little transmitter. It's really handy for sending data from one TNC to another, or being able to control it remotely. I think I've covered all of the basic pins. Let me talk a little bit about the circuitry here. This big guy right here is the voltage regulator. This thing here will take whatever up to 32 volts that's fed in through this barrel plug and then step it to 5 volts, and that of course ends up being the source for the 5 volts here and here when it's hooked up to batteries. These two canisters here, these black canisters with the gray stripes, they're capacitors, and they work like water towers. And what they do is they store electrical current, and if there's a spike or a transient dip in current, for example when you start a motor, these things will dump their electrons into the line feed and then offset those waves. So these things become filters for noise. And last but not least, this guy is open. These are not coated. Okay, any of these circuits here are not coated. So therefore, anytime you're mounting this device, it needs to be on some sort of a standoff, which is why we mount them on these things on the motherboard. Okay, you cannot allow the bottom of this board to touch anything metal, or it could potentially short out any of the circuitry. So I think I've covered the motherboard. We talked about all the sockets, the pins, and the jumpers. Oh, one last thing. When you are working with this thing, and this is super important, these little USB connections are, if you look carefully, there's 2 tiny solder joints right there, and then 5 little solder joints right there. So this cable becomes a pretty long lever, okay? And one of the problems that kids have is they'll lift up on this, or they'll shove the entire thing into their toolbox or their bag with the cable connected, and that causes this to be torqued up. And I can tell you that this socket right here rips off the chip really easily. Okay? So whatever you do, don't do that. All right? You're best off to simply pull it out straight and then transport it like this, unless you are certain you can keep that cable from being torqued up, because it will in fact just rip that off, and there's no way for me to put that back on. So hopefully these 2 videos or these 3 videos are useful, and I'll see you guys again soon.